The release began like any other, a fresh set of breathtaking images captured by the James Webb Space Telescope, blending cosmic beauty with scientific accuracy. However, hidden within these photographs was something entirely unexpected, an image so intricately detailed, so technically unprecedented, that even the scientists were left in awe. But that was only the beginning. Upon closer examination, researchers uncovered a previously unnoticed structure. What was intended to be a routine calibration test soon turned into a groundbreaking discovery. Stay with me, because one of these images could redefine everything we thought we knew about our solar system and the galaxy itself. When NASA's team directed the James Webb Space Telescope toward Jupiter, their goal wasn't to create viral photos or generate public excitement. Instead, they were pushing the limits of one of humanity's most advanced scientific instruments. Imaging Jupiter is notoriously challenging in the infrared spectrum. The planet is incredibly bright, moves swiftly across the sky, and is surrounded by starkly contrasting elements like rings and moons. This made it a worst-case scenario for Webb's sensitive optics, yet the results were anything but disappointing. In just 75 seconds of exposure, Webb produced the most remarkable infrared image of Jupiter ever captured. The Great Red Spot, a colossal storm larger than Earth, emerged with unprecedented clarity and contrast, revealing detailed storm bands, energy flows, and atmospheric layers never seen before. But that wasn't all. For the first time, Jupiter's faint rings appeared in sharp focus, and its moons, especially Europa, shone brilliantly. The most astonishing detail was the shadow of Europa, cast perfectly across Jupiter's surface, creating a haunting and beautiful cosmic eclipse. This was not merely a technical victory, it was a profound statement. A telescope designed to peer billions of light-years into the early universe had delivered an intimate close-up image that shattered previous expectations. Webb proved it wasn't just a window to distant galaxies, it was a powerful magnifier of our own celestial neighborhood. This revelation alone transformed our understanding. While the scientific community marveled at the Jupiter images, Webb quietly provided another stunning photo, the Southern Ring Nebula, or NGC 3132. This was initially a standard target for color, calibration, and structural analysis, a well-studied nebula formed by a dying star shedding its outer layers, creating a glowing shell of gas and dust. But Webb's unmatched infrared sensitivity revealed far more. It pierced through the nebula's gas to expose the binary star system at its core, one star nearing death and its companion still burning brightly. Surrounding them were concentric rings of expelled material, layered like cosmic fingerprints, each marking different stages of stellar shedding, much like tree rings record a tree's life. The image itself was stunning, but the true breakthrough came when someone zoomed in on a thin beam of light, slicing through the nebula's lower edge. This wasn't part of the nebula or scattered gas. It was an edge-on spiral galaxy, perfectly aligned behind the dying star, cutting through the scene like a cosmic blade. Scientists had never seen it before, not because it was absent, but because no other telescope could peer through the dense fog of stellar death. Webb had done the impossible. Suddenly, what seemed to be a simple image of a nearby planetary nebula became a double portrait, one of stellar death and one of galactic life thriving beyond it, a powerful reminder that the universe never tells a single story but layers many, waiting for the right observer to uncover them. To most people, these images are simply stunning, but for astrophysicists and planetary scientists, they represent something far deeper, data-rich marvels. Every pixel of the Southern Ring Nebula and every ring encircling Jupiter is packed with spectral data, light broken down into elemental signatures. In the nebula, Webb's instruments detected distinct traces of hydrogen, oxygen, carbon chains, and hydrocarbons, molecules essential to life as we know it. These aren't just random gases floating in space. They are the chemical building blocks of future solar systems and biology itself. Even more impressive was the efficiency. What once took months of data collection was now accomplished in seconds. In an extraordinary twist, the light from the background galaxy passed through the nebula on its way to Earth, turning into a natural probe. Its spectrum changed as it traveled through the gas and dust, enabling scientists to analyze the density, composition, and temperature of both objects simultaneously. Two distant entities billions of miles apart, read as one story. This goes beyond pretty pictures. It's a profound discovery that even accidental features, hidden galaxies, and unexpected shadows carry vital scientific meaning. These final images don't just prove Webb's capabilities, they prove that the universe is constantly communicating, and at last we are beginning to listen. Beyond the science and beauty, there is a deeper significance. These images remind us that space is not a cold, lifeless void, but a vibrant archive. The dust in the Southern Ring Nebula will drift through space for eons, cooling, combining, and eventually forming new stars and planets. This includes the organic molecules Webb detected, hydrocarbons fundamental to RNA and DNA, essentially the seeds of life, traveling through the vacuum in search of a new beginning. Similarly, Jupiter, with its intricate atmosphere and icy moons, especially Europa, might be harboring life right now. The shadow cast by Europa was not just a technical feat, but a symbolic one. A moon with a subsurface ocean imprinting its presence on a gas giant, captured by a telescope located 1.5 million kilometers from Earth. These are not coincidences. They are cosmic reminders that we originate from the stars, that we are made of stardust like the nebula, and that we are part of something unimaginably vast, yet we have the ability to perceive it. The James Webb Space Telescope was never just a machine. It was a question sent out into the universe. Now finally, the universe is beginning to answer, not with words but through light, chemistry, ancient structures, and distant echoes. These first images may only be the start of something much greater. One of the most mind-bending aspects of Webb is not just what it sees, but when it sees it. The light it captures is ancient, often from galaxies that no longer exist in their observed form. When Webb peers into the deep field, it literally observes the universe as it was billions of years ago, long before Earth formed and before our Sun ignited. In a recent deep field composite, scientists noticed something astonishing: a galaxy with an unexpectedly mature structure. Unlike the chaotic shapes typical of early galaxies, this one displayed clear spiral arms, order and symmetry, features thought impossible so early in cosmic history. This discovery is prompting researchers to rethink galaxy formation models entirely. How could such a young galaxy be so developed? It challenges everything we assumed about the early universe's evolution. Webb isn't just showing us distant objects, it is reshaping our understanding of cosmic timelines, a realization that is as philosophical as it is scientific. Every time Webb focuses on a celestial body, it's more than a photograph. It's spectroscopy, breaking light into its elemental components, essentially reading the barcode of matter. This allows scientists not just to identify objects, but to track their evolution. In recent studies of exoplanet atmospheres, Webb has detected chemical markers never seen before with such detail: water vapor, methane, carbon dioxide, and even possible traces of ammonia. The precision with which it measures these gases on worlds hundreds of light years away is revolutionary. For example, one hot Jupiter-type planet revealed cloud formations and temperature gradients suggesting complex weather systems. Another, smaller and cooler planet showed a chemical makeup surprisingly similar to Earth's, raising exciting questions in astrobiology. While no definitive proof of alien life has emerged yet, it's clear that Webb has the sensitivity needed to detect signs of life. The question now is not if, but when. So what do you do when you begin to observe phenomena that defy description? This is the dilemma astronomers face after months of analyzing Webb's data. Some distant galaxies exhibit structures unlike anything seen before. Massive flower-like clusters of stars arranged in seemingly impossible formations, streams of plasma stretching hundreds of thousands of light years, and entire galaxy walls, distorted by invisible gravitational lenses. These images challenge not only scientific expectations, but also our language and imagination. There is an ongoing conversation about the need to develop new terminology, metrics, and conceptual frameworks, because Webb isn't just filling gaps in knowledge, it's opening entirely new dimensions. It's like discovering color for the first time in a world previously limited to black and white. In this sense, the telescope is not merely a scientific instrument, but a translator bridging human perception and the cosmos's true architecture, challenging our very notions of what is comprehensible. While Webb continues to scan distant galaxies and dying stars, its most profound impact may be right here on Earth. The more deeply we explore space, the more fragile our planet appears. The clarity with which Webb reveals cosmic chaos, collisions, and creation reminds us of how rare and precious Earth's stability truly is.